Every single day, you and I, we're sending trillions of messages whizzing around the globe. Emails, videos, you name it. We just expect them to arrive instantly. But here's the thing. The internet isn't some perfect, straight highway. It's a massive, tangled web where things are constantly going wrong. So how on earth does anything actually get where it's supposed to go? Okay, let's dive into the brilliant system that keeps our digital world running, not by preventing failure, but by planning for it. I mean, really think about it for a second. You hit send on an email in, say, London, and moments later, your friend in Tokyo is reading it. What kind of crazy journey did that message just take through a network that's always breaking and fixing itself? Well, it's not magic, but it is a beautifully engineered process that works a lot like a global postal service, but, for data. Okay, so to really get this, we've got to meet the star of our show, the hero of this journey, the IP packet. This little thing is the fundamental unit of information that makes the whole system tick. See, you can't just fire a whole movie file across the internet in one giant chunk. The pipes just aren't big enough for that. So the system does something really clever. It chops up every big message, whether it's an email or a video, into thousands of these smaller, bite-sized pieces called packets. Now, each one of these IP packets is a tiny piece of your original message, and each one is wrapped up with some super important info. It's got two main parts: the data, which is the actual stuff you're sending, and a header, which is pretty much its shipping label with all the instructions on where to go. This header is the brain of the whole operation. It's got the from address, that's the source IP, and critically, the to address, the destination IP. The bigger part of the packet is the data itself. That's the little piece of your email or video that your friend will actually see. Honestly, the easiest way to picture this whole thing is to think of a regular old letter. The header is just the envelope, right? It's got the to and from addresses written on it for the mail carrier to read. The data is the actual letter inside that only the person you're sending it to is supposed to read. Simple, right? All right, so our little packet has its envelope, it's addressed, and it's ready to hit the road. Now it starts its journey, hopping from one special computer to another, and these are basically the postal workers of the internet. We call them routers. And the whole process is this really simple repeating loop. First, your computer hands the packet off to your local router. That router takes one look at the header and reads the destination address. Then, based on that address, it yeets the packet to the next router that it thinks is a little bit closer to the final destination. And this little game of hot potato just keeps going, router to router, until the very last one in the chain delivers it. Okay, but that third step, that's where all the magic happens. I mean, how does one router out of millions on the internet know which wire to send our packet down to get it closer to its goal? So a packet shows up. The first thing the router does is look at that header. It couldn't care less what's in the packet, your email, a cat video, whatever. Its one and only job is to read that destination IP address. That number is the packet's North Star for its entire trip. But wait a second, just knowing the final address isn't enough, right? The internet is this massive, tangled web of connections. How does it pick the right way to go from all the possible options? Well, it's got a secret weapon. It's called a forwarding table. You can think of it as the router's personal little GPS or maybe a cheat sheet. It's just a list that says, hey, if a packet is trying to get to this general area, send it down that specific wire. Now get this, a router can't possibly keep a list of every single IP address on the planet. I mean, there are billions. That would be insane. So it does something way smarter. It just looks at the beginning of the address, the prefix. So for our packet trying to get to 91.198.174.192, the router just glances at the table, finds the entry for 91.198, and knows, aha, send it down path number 2. Super efficient. So the system of packet hopping from router to router, it works beautifully most of the time. But, the real world is messy. Fiber optic cables get cut, routers overheat and die, networks get totally clogged. What happens when the perfect plan suddenly falls apart? So that leads to the million-dollar question. If that perfect, direct path suddenly gets blocked, is that it? Is our packet just gone forever, lost in the digital void? The answer, thankfully, is a big no. And the reason why really gets to the heart of what makes the internet so amazing. It's all because of a concept called redundancy. And it is, without a doubt, the internet's secret weapon.
Redundancy is a simple idea, but it is so powerful. It basically just means that between any 2 points on the network, there's never just one road. There are always backups, always other ways to get there.
Okay, let's make this super clear with an example. Let's pretend our packet needs to travel from a computer in Oakland, California, all the way over to a server in New York City. So on a good day, when everything's working perfectly, the routers figure out the quickest, most direct route. In our little map, that's a straight shot from Oakland through Austin and on to New York. Easy peasy. But uh-oh, let's throw a wrench in the works. Maybe a construction crew accidentally cuts a fiber optic cable. It happens. And just like that, the direct link between Austin and New York is gone. The best path is now totally broken. And this is where the genius of the network really shines. That router in Austin doesn't just throw its hands up and say, well, I tried. Nope. It looks at its map again, sees its favorite road is closed, and immediately finds the next best detour. It reroutes the packet down to Tampa, and the router in Tampa sends it right back up to New York. The message gets through. It took a slightly longer trip, but it got there. So here's the big takeaway, right? Redundancy is what makes the entire internet fault-tolerant. The whole system is built on the absolute certainty that pieces of it are going to fail all the time. By making sure there are always multiple paths, it guarantees our data has a fighting chance of arriving, keeping us all connected. And this wasn't some happy accident. This was a core design choice from the very beginning.
Which leaves us with a really cool thought to chew on. The internet isn't strong because it's perfect. It's strong because it was designed from day one to expect failure and gracefully work around it. It literally works because it's designed to break. So what else in our world, maybe even in our own lives, could be made stronger, more resilient, if we designed it with the expectation that things will inevitably go wrong?